Okay, so guys, remember this. On your study sheet, you're gonna make a note to watch out for identicals. When it's a word, I hope that's the first thing you're gonna check for. Are there two I's, three I's? Is there four M's, two M's? Like, is there double, right? Is there identical? That one, I would really hope you don't miss. There's no exception. There's not a single exception. When you see a word and you see identicals, you need to divide that out. For every letter for every occurrence, you need to have a specific factorial down here. That is not negotiable, that you have to take care of that. Even if they say there's no restriction, that is still, we don't count the A's being moved around. We don't count that as a separate permutation. Got it? Now, where it gets a little trickier is when you have like balloons or I even think, right now I'm thinking of a coin question. If you have a bunch of loonies, a bunch of toonies, a bunch of quarters, right? You have to watch, is it saying that they're identical, they all look exactly the same, or are they all unique? We all know that coins are technically, most coins are unique, right? Because they all have a different date stamped on it. As soon as there's something that distinguishes them, it's a completely different coin. So having a bunch of toonies, it doesn't change anything if they're identifiable, if they're distinguishable, okay? But balloons, if there's nothing, if you're like, oh, marbles, balloons, I've seen decoration, like Halloween decoration or any sort of decoration where everything looks exactly the same, you have to make sure you divide out identicals because we don't care if we move the identical items around. So let's go to 26, just so you have it in your notes. Okay, Mississippi. Mississippi has how many letters? 2, 4, 6, 8, 10, 11. N is 11, okay? Then we've got how many I's? 1, 2, 3, 4 I's. And we've got 4 S's, 2 P's, and I think we're good there. So these are identicals, right? So if there's no restrictions, if you want to arrange the letters in this word, you go 11 factorial, and you divide by whatever is there. 4 factorial, 4 factorial, 2 factorial. Now, I think most students know how to do this, but they still make a mistake when they enter it into their calculator. So, if you're going to do this in one shot, you have to put brackets around the items that are multiplying in the denominator. So if you want to go 11 factorial divided by whatever is down here, you go for it. There's one thing you need to watch out for though. There are instances where your calculator cannot handle big numbers, like factorials that are really, really big numbers. What do you have to do in that case? I showed you how to break down factorials, right? Remember, breaking them down and then canceling, you need to do that, okay? In this case, 11 factorial is 39, 916, 800. The denominator, if you multiply it all separately, is, this is 24 times 24 times 2. That's 1152. And so you get 34,650 ways. It's actually not a whole lot of arrangements given that many letters. And the reason is because there's so many identicals, we don't count them. Okay, so there's 4 S's, right? Is that one. 4 I's, and 2 P's. Okay, so you remember that. P's. There you go. So there we go. No further restrictions. Okay. So this will always follow us no matter what. We're going to have to divide our repetition. Okay. What about this? Words must start with an I. Okay, so then you have to go, I'm going to do it this way. Just one. There are 4 I's, so I will just do that. We've got 4 options for the first one, but given that they're all identical, I really say, well, I don't care about the other three cases because they're exactly the same. So there's just one option. Then we multiply it by, how many letters are left? 10, right? So this would go 10, 9, 8, 7, 6. So I'm just going to go 10 factorial. And I have to do this again. The S's are still all in here, right? So there's 4 S's. How many I's are left? Like, remember, I do one case at a time. If I take one of the I's out, in here I'm left with 3 I's. Okay? And then 2 P's. So I will make a note here. Only 3 I's left. One I removed. Got it? So this is the, I'm going to highlight that one. I used to have 4, now I only have 3 I's left. Those I'm dividing out. In case it's Monday, you're like, I don't know what happened here. How did this turn into 1? I don't get it, Mr. Erickson. Remember, there's 4 I's. There's, right, one of the I's here. One of the I's starts here. You start another word with an I. Start another word with an I. Okay, so technically, each one of these cases starts with a 1, right? You remove I, has to start with an I. Then you would have times 10 factorial, 10 left. And remember, you still have all four S's are still there. So you have to divide that out. Since you removed one of the I's, it's staying here. You've got 3 I's left. And you've got 2 factorial here. Let's do this here real quick. 10 factorial. Where am I? Where am I here with my key? 10 factorial is 3,628,800. 4 factorial, 3 factorial, 2 factorial is 288. If you divide that, you get 12,600. 12,600. This first case, all right? This first case. Got it? What about these 3 cases? Do I actually need to calculate them? The answer is no, because if I start with an I, it will look exactly the same as this first case, right? This one will look exactly the same as that. So these cases are not to be calculated. And that's why this work just simplifies to this, okay? Where you have one I, we don't consider the other I's, and then it's 10 factorial, just like before, 4 factorial, 3 factorial, 2 factorial, okay? So that's how we treat this, okay? Identical. So this is our final answer here. Okay. I forgot to write down what the answer is, but it is the same. Okay. I'm just going to highlight the 3 here. All right? You look excited, I know. Now, what if we start with a P? Let's, this one I'll do a little bit faster, right? So we've got the front has to be a P, and we happen to have 2. We just get rid of that one case. We don't care about the other case. We only care about the one. And remember, it's 10 factorial divided by 4 factorial for the 4 I's. They're still in here. There's still 4 S's. And how many P's are left? Yeah. Sure. How many P's are left? One P is removed, right? One P is being removed, so there's only one. Only one P left. Okay? One P removed. Okay? So this will just be, I'll just give you the answer, 3628, 800 divided by 576. This is 6,300 ways to do that. Yeah. The letter M? Yes. Yeah. All the other letters, like you remove a P, so everything else is left. Yes. All the other letters remain. Okay. What about this one? This one mixes. Let's put a little subtitle here. Identicals meet, or identicals meets together. I'm going to say this one is rare, but then at least you have at least one example. If you come across another one, you should tackle it, okay? How do you want to start? I'm going to start with the fact that I have 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what I do when I'm supposed to keep things together. The I's are together. How many I's are there? 4, right? These are my I's, and there's 4 of them. I can move them around. Mr. Dirksen, but they're identical, right? Yes, we'll deal with it in a little bit, okay? I'm dealing with keeping them together. If you keep them together, how do we do the zooming out part? Do you remember that? You count this as one slot, so 1, 2, 3, 4, 5, 6, 7, 8. So this will be 8, 7, 6, 5, 4, 3, 2, 1. So right now, I'm not going to go equals, guys. I'm going to go arrow. This is going to help me taking care of the things staying together. Okay? This is Zin. This is Zout. Zin, Zout. Zoom in, zoom out. That's when you consider this as one slot, right? Okay, and now what? Yeah. Now what? I need to still take care of the identicals, right? So we still do what we did before. Watch this. We've got 4 S's. We've got 4 I's. And we've got 2 P's. These are your S's. These are your I's. These are your, this is rare, guys. So if you're a little troubled by this one, it's rare. I can be quite confident that on an exam, I don't think they're going to go to this level, okay? However, now, what can we do now? We can cancel things out, right? Before you proceed, I would say, get rid of this. So it's just really 8 factorial divided by that. 8 factorial divided by 4 factorial, 2 factorial. And this gives you 4,320. This is 24 times 2, that's 48. That is 840 ways. Yeah. Why the I's? Why do we have them here? Because the eyes are still technically part of this whole arrangement, you're keeping them in. And what's happening here, if you think about it, the 4 factorial here with the eyes gets canceled out by one of the 4 factorials here. Really, we just count this as 1, because moving the eyes around isn't going to change anything. So the canceling out here takes care of that. So technically, theoretically, I should have canceled maybe the 4 with this 4 here, because the eyes, but it doesn't matter. 4 factorial cancels with 4 factorial. Okay? Complicated, right? Okay. Any questions? Okay. Let's, I want you to go right now and practice page 40. I know, why is it on 40, right? Because technically I don't want you to see it until later again, but we'll try page 40. Very similar, very similar to what happened in this page. So have your finger on this page or fold a corner and then go back and forth. That's your AC right now. Just try it.